Good morning, good afternoon to everyone out there who is already with us today. It's great to be joining you all the way from Europe. Normally I'm in the Philippines, but today I'm in Germany, visiting my mother here in Germany and doing a couple of things that need to be settled. And we have our other guests all the way from the Netherlands, which is not so far away from Germany. So complete European lineup, but we welcome everyone from wherever you are joining us all over the world. It's great to have a lot of interest in this webinar today, which is focused on IAQ in schools, the intersection of health and learning. And it's going to be a fascinating topic. We really have a great case study from the Vinci College in Holland. We will really hear about how the project was initiated, how the students were engaged, how learning was combined with IAQ monitoring. There's a lot of innovation here. But before we get into the real meaty case studies, let me share the opening poll with all of you so that we get a little bit of an insight of what our audience is thinking. Now I need to put my glasses on, otherwise I can't read the small print. The question is, what are the possible challenges and concerns that schools might encounter when monitoring and managing indoor air quality? And this is a single choice answer. You have to decide which is the most important challenge concern for you. Is it familiarity with indoor air quality monitoring technologies? Is it the availability of finance? Is it the lack of involvement of students, parents, staff, school location and building time? Overwhelming number of different indoor air quality devices and brands, and lack of knowledge on the importance of monitoring indoor air quality. So give us your answer, what you think is the #1 issue that is currently the challenge that we need to overcome to make this happen at a much more comprehensive and larger scale. We have about 60% of people now answered that are on the call at the moment, but the number goes up as people are still joining. So let me finish the poll now and share with you the results. Now you should be able to see, and it's very interesting, the #1 choice that half of you actually answered is the lack of knowledge on the importance. So we really need to educate, do a lot of awareness raising. That's the #1 barrier. Now, the second barrier, which is kind of very similar, familiarity with indoor air quality monitoring technologies. That's a bit more of the technical aspect there. And then availability of funds. I thought maybe that would have been the #1 choice, but it's only the third choice in the running. And then one person as well said lack of involvement between students, parents, staff, and so on. Now, this is very, very interesting, interesting results. So the importance and the awareness on the whole issue, that's the #1 stumbling block. We have a great case study today, and the first presentation will come from Dan Wortel. You can see behind him, and the Dutch name of that building is too difficult for me to pronounce. You can give us that enlightenment in a minute, but this is called the Sustainability Factory. I am gonna really be interested to hear the details of what happens in the Sustainability Factory. But in addition to Dan managing the Sustainability Factory, he is as well the innovation manager at the Vinci College. So that's really the intersection of overall big picture sustainability and then working on it in a student and school environment. So he will give us the context of the case study. How did it come about and how was it conceptualized? So Dan, over to you.
Thank you, Matthias. Welcome, everybody. As Matthias mentioned, we're very proud of the Sustainability Factory, and in Dutch it's called the Duurzaamheidsfabriek. Don't try to pronounce it, but it's when you're in Holland, you can say it and they know it. I will start sharing my screen now with a short presentation on the Sustainability Factory and the project. share. Can anybody see my screen, Matthias? Okay, thank you. So my name is Daan Wortel. I'm the managing director of the Duurzaamheidsfabriek, but I'm also innovation manager for the Vinci College. And that's a very interesting part because the Vinci College is a college with over 9,000 students divided over all different educational programs. On basis, there are 3,000 on healthcare, 3,000 on technology, and 3,000 on logistics and economics. So then you have an idea what the scale is of the school. But we also saw the same challenges as you already did in the poll, because we, I want to go to the next slide. Yes. We want to see what problems we have at school and be in some sort of facility space for these projects, but also on real life situations. And this is what we call, we increase the innovative strengths by linking innovation to the lifelong learning programs. It's not just a project. It's in cooperation with companies, in cooperation with real challenges. We work together with students, and the same on air quality, we do that. And this project was one of the smart city initiatives we did with uHoo, and we said the school has to monitor its air quality, and its air quality needs to be monitored, because when the air quality is good, the educational results will also be will be better. That's the assumption. But then we have to measure some things. And how do we measure? We don't even know what technology there is. So you gave us the possibility to measure. And so at the end, we did this technology. We implemented this technology as part of the educational program with technology students. So what you see is that they got trained in the technical side of the sensors we use, but also in how to install them within the different buildings. And that's interesting, because now you're starting up and saying, hey, what do we need to know within our school programs, and how do we install it, but also how do we explain it? So the students also will get more 21st century skills. They have to communicate with one another. And at the end, maybe it's interesting to see is that the innovative technology is for younger people easier to understand. They already grow up with it. So they like these projects as part of their program, but also that they get aware of the innovative technologies already there. And that's what we do in a hybrid learning environment. So the school is a learning space. The sustainability factory is a learning space, but it's also a development part of the whole school. So you see that all these different things, vocational education, challenge-based learning, different teams of students from different levels of education come together. And the Vinci College is investing in that. And that's my role as innovation manager. We need to invest in these projects and develop them more and work together with startups in these settings. So this is what we did, is we did a startup project. You see one on the other hand is electrical power boats, no more fossil fuels anymore, but they built the boat in the sustainability factory together with students. The other project, what we'll focus on right now, is where Bram is coming into play, that he did the real implementation for the students and the projects in the use of technology. So that was, in short, my presentation. And I give the word now to Bram, if I may, Matthias.
Let me first ask you one quick question, Dan, because this is a really interesting example. And I love, some of the things that you mentioned here. If air quality is good, the educational resource is good. You mentioned 21st century skills and this collaboration, the holistic with startups. But I want to just follow up on this. What do you mean with if the air quality is good, the educational resource is good? What did you mean with that expression?
What I mean with that is that we learned if the there's too much CO2 level. I'm looking at Bram to say it correctly. When the CO2 level is too high, the students will get sooner tired, and the capacity to grasp the knowledge will be more difficult. So if a school is well situated, well facilitated on this part, then you will, the assumption is that students will learn easier, more quickly. That's what I mean with that.
Great, great. Thanks for clarifying that, Dan. And we will ask Bram to go a bit more into detail on those points. Dan is introducing the context, because I think it's very important for us to understand the context, that this is a holistic approach. It's not just about monitoring the air quality, it's about getting the students involved in a new learning and innovation process. Now, Bram, over to you. You were the startup company that actually did the implementation, right? So you could build your business partially with this project, which is, again, another excellent innovative concept of the sustainability factory. So over to you to give us a bit more detail on how the whole thing actually happened in practice.
Yes, thank you very much, Matthias. Thank you for the introduction. Hello, everybody. My name is Bram Dees. I'm the owner of Hakon, which is a company in indoor air quality. And what we did, well, I met with uHoo, and they told me all about the product development that they had done. And I saw a lot of opportunities to take this product and use it in the larger context. Because measuring is one, but knowing how to measure and what to measure and when to measure, that's a lot, well, that's a more comprehensive view. And that's what we wanted to develop. And then the opportunity came to work together with Dan and with uHoo and the students to explore a lot of different directions, development directions. And we just went through them one by one together with the students. So what I will tell you is I will tell you about the project that we did, how we did it, the different parts, some challenges, and some great things we found. So we started off with 35 sensors and with at our side little knowledge about indoor air quality at that point, which was a big challenge. So we had devices and, well, first thing we did was just setting them up and trying to see what they actually measure, how to install them, if we have our Wi-Fi settings correct, because if you, as you may know, the Wi-Fi at schools may be quite secure, and therefore something as an IoT sensor can be quite scary for a school, for the IT department. So that was already the first challenge straight away. And from here on out, we started to create this toolkit, try and find maybe different products, maybe different services to use the sensor, not just on its own, but in a consecutive row of actions, which ends up as a workflow, as I will tell you at the end of this small presentation. So the student projects, what did we do? Well, first, like I said, was installation, which was a challenge on its own. But also, if you tell the IT students to install a sensor, they will be quite able to do that. But it's a lot harder for them to convey the message to the users of the building, what the sensor is actually doing and why it's so important. So it was for us interesting to see how the installation went, and for them really interesting to learn a bit more than just IT itself, also learn about communication to the end user. Then we started testing, measuring, and it was quite quickly that we found that we get a lot of numbers and a lot of data, and the uHoo app really translates this very, very well to a graph, different graphs of different timescales. But we thought maybe it's even possible to go one step further and just give a sort of a traffic light. So the green, orange, and red. And we did this in two ways. One was create a floor plan and import the data from the uHoo sensor and just show in the different places where the sensor was placed, if it's green, orange, or red, just one color for the entire thing. And then I'm gonna skip to the traffic light, which you also see in the bullet points, where we did basically the same thing, but then on the sensor itself. So we built a small addition to the sensor, showing the air quality at that specific sensor at that place, which is a way to see it immediately. This one way is to see it through the app, but then you also see it on the sensor. And also we worked with 35 sensors. So we had this technical start, like the things I just mentioned. Okay, we have an installation and we go from data to some insight. But now how do you actually use those sensors in the practical environment? And we found out that when we moved to a second building, the healthcare building of the Vinci College, that we had 35 sensors, but many more rooms. So how do you choose a room? And that's where we involve the students from the healthcare department to think with us, okay, how can we gather data about how people experience their own building, their own school, and how can we translate that to a decision where we're going to measure? And that's what we did in the questionnaire. And then from there, well, there were, I'm just going to stick to this project for now, but there were subsequent projects as a spin-off from this project. This was just a start. And that's where students had roles as well, both from the healthcare and from the IT part of the school. So I'll just share very, very briefly some measurement results. Once the warm weekends, we found out that if you measure air quality in this specific building from healthcare in the Vinci College, that every day you see the cycle that you expect of a raising temperature when the heating goes on and the temperature goes down at night. But then all of a sudden we found that in the weekend it's a lot different. And I will show you that in a second on the next slide. Another thing Dan already mentioned for us is CO2 in classrooms. Turns out that higher CO2 really quickly decreases the cognitive capabilities of both students and the teacher. And that just makes lesson times, well, less productive. It's harder for people to keep up. And in the end, they will learn less in the same amount of time. So that really got the discussion going within the Vinci College. Okay, how can we optimize CO2, but also facility management said, well, but without too many costs. And then we got the discussion going, what's the value of your lesson time? And turns out that the value is actually quite high. So priority is really to provide a great learning environment. Another thing we found is that if you look at the laws and regulations, then you see that it's not really meant to decrease virus transmission. And at the point that we started this project, there was no corona going on yet. So it wasn't too much of a problem. We knew that people got sick, and you know, if somebody has the flu, then somebody else might get the flu as well. And then we really saw that all of the laws and regulations, but also standards in the installation branch itself, is not meant to prevent virus transmission. Which was a discussion on its own. Well, I promised you the graph of the warm weekends, and here it is. You see the 7 days of the week starting on Monday, and you see every day has a cycle where temperature goes down through the night, and then it goes up again, and then it goes down again every day. And then you look at the weekend, and you see that the temperature was just going up. It's a really simple change, of course, to tell the installation not to heat the building to very high temperatures at night. And so we did, and that saves a lot of energy. And this is something that Da Vinci College was unaware of at that point. So from here, we created this workflow, and I've tested this since in the healthcare branch with a home for elderly people. That's where we really tested out this workflow again. And I will show you that what we did at Da Vinci College, all the steps we did in a small way, how that translates to an actual workflow for my company, which I now run on this workflow. So that's a lot of words for one slide, but I'll help you through it. first thing, I come in, I just check the paperwork. What contracts do you have? What installation is there? How was it designed, to which standards? And then from there, you check if the installation actually comes up to that. Does it actually create the flow rate that you need? Maybe we need to check that in several places. Maybe that's checked annually, like it should be, but which often is not the case. So from there, okay, we have a sort of idea of what it should be and what it actually does, and then we go to gathering the known complaints, because there's always complaints in every building, and maybe that's not always the fault of the environment. Maybe it's also sometimes the people, and we have to find out what their complaints are. And from knowing their complaints, we know where to measure, what to measure, and what to look out for. And then we have a measurement itself, and we go through the data, we draw our conclusions, and we go to an advice. From that advice, you get an end report saying what we concluded in all the observations, from paperwork to installation to the measurements. And we will always find some things which are a problem or which can be improved, and we will tell them about the health issues that they might have if they don't change this, and then suggest partners also to execute the solution that we have provided for them. And solutions are always there's three options. It's always the same. First is behavior. If CO2 levels go up, you can decide to put less students in a room. If that is not an option, because you have too many students or too few teachers, then you will have to change the installation itself. And from there, then you probably by then you apply to the level that the law has ordered you to make, but you can go further. You can do a lot more, because there's a lot of people with asthma and COPD, there's people with bronchitis, there's people who are very vulnerable to whatever is in the air, and they will really feel the difference with the bad air quality. And even if you get to the level that the law requires you to get, it's often just not great. It's often not enough. So from there, I also added air purification to really, if ventilation is about gases, air purification is about particles. So we also take out the particulate matter, but also viruses themselves. And it really makes the air really, really clean. And now you have a workflow where the sensor actually provides essential insights and really makes it possible to make the environment that much better than it was. So this is what we learned in this project, and thank you for that. And I will now give the floor back to Matthias.
Oh, all right, great, excellent, very, very interesting case study. You are encouraged to put your questions in the Q&A tab at the bottom. I see most of you have used the chat function. It will be easier for us to manage them if you put them in the Q&A section. Just a quick question for you, Bram, one or two questions. You were indicating that there was a linkage between the CO2 levels and the alertness and learning ability of the students. How did you measure that? Did you have a quantification, or was it just the observation, the empirical observation that people just got tired when CO2 levels were high?
There is definitely an empirical observation. It's something you can see, but then it's hard to quantify. So there's two ways in which we observe this. One is the qualitative way, which was just observation and talking with teachers, although it's hard for teachers to make to see the difference between a higher temperature and a higher CO2 level. So that's where you have to make it objective, and that's where you just refer to literature, just scientific literature, which says in this specific case, to give the number, at a CO2 level of 1000 ppm, which is below what you have to do required by law, you'll already miss out on 15% of cognitive capabilities. That's just concentration and learning abilities.
Yeah.
So
I used to work in an office in Metro Manila, and there was always a small meeting room that people felt very sleepy in. And, you know, the reason was the central air exchange did not capture that meeting room. It was just installed after the open plan office was already there for some time. And then when I used the uHoo and showed them, hey guys, we have more than 2000 ppm CO2, that's when finally people realized the root cause of this sleepiness or lack of productivity in this small meeting room is based on the fact that there's no fresh air coming in. Yeah. One other quick question. What was very interesting in your case study was actually nobody knew that the empty building was being heated full blast every weekend, right? The amount of money, the amount of carbon footprint that was kind of wasted there. Did you get an estimation how much money they saved after adjusting the procedure with the facilities department?
It was not quantified actually, and I think it should have been. And so in this specific question, but also in many other questions that go into more detail, I find that there's more options to add more services around this workflow. For now, it's still relatively technical, but we can also refer to the responsibility that people have to create a great environment, and also the responsibility in sense of sustainability and just really manage their resources very well. So there's more options there to increase this workflow, not just for making it the technical installation as good as it can be, but also the broader environment around that.
Yeah, if you can get it quantified in the future, that would be great, because I'm sure that alone might pay for 50 to 100 uHoo devices, just that energy saving, and then the productivity gain during the education when it's back in the buildings. Again, if that could be quantified, that will as well be huge. Now, I want to bring Dr. Albert in. We have a lot of questions coming in, so we will very soon go to your questions. But Dr. Albert, who is looking after the whole medical sector and other innovations at uHoo, working as well from the Netherlands. He was involved in the conceptualization of the project. So I'd like him to comment as well on what were the main innovation parts and learning parts of the project, Dr. Albert.
Thank you, Matthias, for this nice introduction. It was really, really a great project because, to be honest, it was our first project. And without the funding of the city of Dordrecht and also the innovation funds, we could not realize this project. And we learned a lot about it. Also, what Bram was mentioning, how to deal with the devices, where you should place the devices, the installation and everything. And I think, and also it had a great spin-off, I must say. The students of Da Vinci, they were also involved in a project in the city of Alblasserdam, where we did, on behalf of the province, indoor air quality measurements in 100 households. And they were also involved in the installation, the service desk, and that was a great help. This project inspired us also to go further. And another spin-off of this project was in an elementary school. And I cannot highlight enough as a physician how important it is that indoor air quality is good, because students and also children are in a so-called physical development. So poor air quality affects the brains and the lungs more than in adults. That is something people should realize. And also in the project of the elementary school, I would love, I thought, how can we involve those students in the age of 10, 11 years also? So we developed a kind of education package. So and they had to do it themselves, the measurement. They had to look at the sensors and the green, the orange, and the red. And what does it mean? What does it mean? CO2. What's the influence of temperature, humidity, carbon dioxide, volatile organic compounds, and that was very useful. we did also measurements, and we could see a clear correlation. If the indoor air quality was becoming poor, the students in this elementary school, they got irritated. They were not concentrated. They were looking around. This is also an empirical, because you cannot test it, but it was clearly seen. And they came up also with solutions, because the schools, the rooms were all the same amount of students, about 30. And they have decided to put a wall of plants in one of the rooms, because they find out that CO2 was taken out of the air by plants. And we saw a difference, although it was not statistical difference. So basically, starting at the school and the universities to measure the indoor air quality, I think it's vital, absolutely vital.
Yeah, it's amazing, actually. And I wouldn't be surprised if some of the students who went through this exercise will choose a job related to indoor air quality in the future, because as Dan was saying, these are the 21st century skills and the 21st century jobs as well. So the education part was great. We have loads of questions that have come in. Maybe we'll tackle them one by one. The first one from Tiago is really, what is the standard that was followed to select the quantity and locations of the sensors? I mean, any one of you can maybe answer it, who was involved in that process. Any standards, or you just kind of made it up in a logical way yourself?
I think I can answer that easiest. Thank you for the question. Yeah, in that sense, the quantity of the sensors was a really practical way. As Albert has indicated, this was the first project for you, the first use case. So that was more a financial decision than anything else, to use as many sensors in the school as possible. And since the municipality was involved, that really gave direction for the amount of sensors. As to the location, choosing the rooms themselves was based on the amount of complaints that we got from the different rooms. So we asked a lot of people about a lot of rooms, and it was just a frequency analysis where the biggest complaints were. And then within the room, it's quite logical. You don't put the sensor above the heater, and you don't put it in the sunlight, and those kinds of quite logical decisions.
All right, great. We have the next two questions as well. I think they are linked, Bram, to your workflow that you have identified. One question is, what do you do after you submit the reports to your customers, and really kind of convincing them to do this long term, rather than you having given them just the initial data and reports, and then they think it's all okay? And do you have data with and without air purification for those projects where you've then as well done additional air purification?
Thank you. So those are two questions, I think. What about long-term attitude, and with and without air purification? So the first one is, I think there's two reasons to measure indoor air quality, or two kinds of motivations that people have or give. There's proactive and there's reactive. And I think most people think reactively. So we have a problem, or we have complaints, and we want to get rid of those. So we want to measure it. And if there's no problem, then we can just continue with our lives without changing anything. This is facility management at its best, trying to decrease the amount of complaints with as little investment as possible. And for that, you need a few sensors which can travel through your rooms or through your buildings, and you measure something for a few weeks, and then you will see if there's a problem or not, and you continue. And I think that that's a possible way, and that's a very technical way. That's really getting, okay, are we getting the standards that we absolutely need, and can we stop the complaints with this? And then there's the proactive way, where you really want to know what kind of environment am I offering to my students in this case? And that's where you really want to know about the long-term environment you're offering. For example, if you look at particulate matter, the influence of particulate matter of the very tiny particles is cumulative. So it's important at all times. There is no lower threshold under which there is no harm from those particles. So it's always a problem. And that's where you really want to know the long-term effect. So I think it's not, you know, it's 2021. If we look at what we have and what the possibilities are, I don't think it's realistic to just fix some problems and then continue. I think the attitude that we need is a long-term view, where we just say, okay, you can study with us. Those are the studies you can choose. And you get a learning environment in which you have Wi-Fi and coffee or tea and clean air. I think that's something you're supposed to offer, and therefore also something you're supposed to prove. And just measuring those parameters continuously is, I think, is very useful. I've got about the air purification. Yes, I show customers, I do this test, 1 month test, in which I show them particulate matter levels with and without air purification. And I've got 3 different ways on which I also show them that I clean the air. Maybe a bit too much detail for now, but yes, I do show with and without air purification, and based on that results, people decide to do or not do implement air purification.
All right, great. Thanks so much, Bram, for the comprehensive answers to those questions. Maybe then I'm not sure whether you can take the next one, and then Albert the one after that. The next one is really, how do you maintain the wireless signals from each sensor to the centralized data? I mean, in the Vinci College, how could you guys manage that the devices were always live and always connected?
What we have is on this whole campus, we have our own fiber network. So the hardware is already in place, and each building is firmly connected through Wi-Fi on the fiber network. So we have lots of hotspots for wireless hotspots. Saying that is so there are, I think, never issues with Wi-Fi on the campus at the moment. So on that side, the facilities are very good. It's also for students, of course, that they have access to internet and they have the ability to do the projects online. But you see that the sensors itself, and then I'm looking at Albert, when Bram, they installed the sensors within a few minutes, and then they were all online, and it worked, I think, flawlessly.
Yep.
Maybe that's as well the difference between some countries where the Wi-Fi network is not so comprehensive or too expensive or too slow, and educational institutions might not even have a proper system in rural areas, and the Netherlands, and particularly as well that the Vinci College is a very innovative college. So you guys had all these things in place. That's why this was not a challenge.
I can add to that is that that the schools in the Drechtsteden, the bigger area, are working together as owner of these facilities. So all the schools in this area have the same quality and the same facilities as all. That's what we call digital main port. That's what we need to get a good quality on digitalization.
Yeah.
Great.
Yeah, because
yeah, Albert.
Yeah, because a lot of schools, you know, I think so also, especially in the Netherlands, but also I think in Germany, the teachers are using screens, they're using smart boards, they're using everything. So the connection between all the devices had to be good. One of the things also, one of the lessons learned in the schools was that the teachers, when the indoor air quality was getting less, or there was not a good air quality, they get a signal on the screen. And so they have said, okay, let's open the windows now, or in certain cases, let's go out for 10 minutes so that the fresh air can come into the room and then come back again. So these simple solutions by the alerts giving on the screen of the teachers was feasible. And I think that could also be feasible in other countries.
Great. The next question as well for you, Dr. Albert, from Daddy. Is this sensor also calculate the infection rate of the room? I guess that is really a question on the uHoo virus index, and you were the main author of that, so you should take that question.
Yeah, that's we have built in the so-called virus indicator that is based on certain parameters, and but what we are doing is to look at the environment where the virus would survive. I mean, like people need an environment, but also the viruses. And so we're looking at the environment where the virus can survive, and we are not measuring the virus itself. And also because that is extremely, extremely difficult. Coming back also on the virus index, we are measuring viruses. And at the moment, the COVID virus is going around, but don't forget also the flu. And so children get sick, they get the flu. And that is also being indicated by the virus index. So it is the virus, not specific to COVID, but it's viruses in general.
Yeah. Maybe just to add to that, it's humidity, carbon dioxide, and other metrics that are used as a proxy to give a gauge of how long would the virus survive, or how quickly would it. So you optimize your conditions in your indoor environment to minimize the survivability of the virus. And you know what's interesting now, because we have been so vigilant due to COVID, hardly anyone has been getting the flu during the last 1.5 years, right? So it shows there is a very strong correlation there. Okay, excellent. Now, Bran, the next two things for you. One is, again, I think, linked to your process now. What are the steps you recommend to improve the air quality inside the facility? You can monitor, so I'm sure you have recommended solutions. Now, after monitoring, what solutions did you recommend? I guess related to the Vinci College. And then Charlotte asks, how old are the kids there? And she says, amazing stuff, Bran.
Thank you. Good to hear that it's seen as amazing stuff. That's great feedback. The age of the kids is easiest, so I'll start with that. They are aged, correct me if I'm wrong, Dan, I think they're 16 to 20, 21. And I see a thumbs up, so yes, that's about right. The recommended solutions, that really changes per building, per type of use, per room. So I'll just give a few examples. I already gave one example for the classroom, which Albert also related to, where you just put less students in a classroom. And if that's not feasible, there's always this check that you should do with some regularity, where you check the flow rate of your installation. So you measure the amount of cubic meters per hour that comes through every single ventilation point. And often you will see that there are rooms where there's more than enough flow rate. And you can always divert those with the valves that are in the installation to the correct rooms. And then with measurements, you can, again, make sure that the solution actually worked and that you now have better CO2 levels, lower CO2 levels in that particular room. But there were also some solutions which are just not about the installation, but about behavior, which I gave to a home for elderly people, also here in Dordrecht, where I just finished the project as well. And there we said, well, there's COVID, and as what relates to the virus transmission as well, we should try and do the showers with a closed door, because a lot of those people receive care and are helped. But all those aerosols, all those tiny droplets of water, They really help virus transmission. So we should keep the doors closed and ventilate well after taking a shower. And it's those very practical things that can help a lot. And then always there are some rooms where you didn't improve a lot, or where it wasn't possible to improve, it was too expensive. And that's where I say, okay, just make sure you keep monitoring those rooms continuously, because you might need to intervene at some point in the future, because all rooms and all use of all rooms it's always changing. Classrooms are always restructured every summer. There's always some rooms added together or split, and the installation is not always taken into account. And a meeting room becomes a classroom, or the other way around. More people make use of it. So there's a lot of things that are changing. So rooms that are at risk, I would always continue to monitor after the project.
All right, thanks, Bram. The next question from Darren is as well related to this combination of occupancy, energy, and indoor air quality, merging the data and actually making use of it. How often does that happen in the projects that you do, that clients actually use the data in combination?
So, sorry, can you repeat which three? Indoor air quality, energy, and occupancy?
Occupancy, yeah. Energy consumption.
Energy consumption is generally not the focus when you start measuring indoor air quality. It's a nice to have. It's something you find out later. Recently I had this measurement somewhere, and I said, well, this is not what the project's about, but I saw the temperature profile of this room, and I think you can start the heating half an hour later every morning. And that's where they save some energy. But that's not the focus, because generally when you start doing indoor air quality, the focus is on health. It's simply about health, and energy consumption is a factor which I take into account if I can, but it's secondary.
Yeah, I think it's as well a question of how the client makes use of the data, and how the data gets further aggregated and utilized, which is what Darren is alluding to. I mean, we should actually make that link, because I as well used to work in a building in Metro Manila that had a stupid facility management. Every time it was cloudy outside, people were inside with jackets and coats in a hot climate like the Philippines, because the chillers and the cooling system didn't adjust to the outside temperature or the position of the sun. So there's no connection between the figure of the temperature inside and the control of the central chiller system. And that wastes a huge amount of money, generates a huge amount of carbon footprint, but sometimes people don't care when they pay a flat rate for cooling per square meter rather than for the electricity price. But yes, I think especially the uHoo Aura, with its combination of sound, of occupancy, there's a lot more intelligence that you can put together to optimize the way how you run and control your buildings above and beyond the IAQ. I see Albert nodding. Maybe you have one or two comments on that as well, Albert?
Yeah, also, let me also add, we're also working with several distributors, of course. One of them in the Netherlands is AirTech. And they are giving a report every month about the air quality, but also about the energy savings you could make. So there is, if you work together with several parties, you can provide all these data to the customer. Secondly, you were mentioning also the Aura. uHoo is more focusing not only on the indoor air quality, but also on the indoor environment. So we are looking also not only at the humidity, temperature, CO2 levels, but also several PM particles, the small ones, the ultrafine particles, and also looking at light and also the sound. And also we are, because there are new regulations coming up in Europe, especially also in Belgium, there's an obligation that every school has to have the CO2 monitor in the classroom. And then you have to show what the CO2 levels are. Also, we have thought about it, how can we do it with the uHoo home version and also the Aura. So, but we can now indicate there's a light going on, a sort of kind of traffic light, when the CO2 levels are not good. So we are fulfilling with these developments the criteria of the government. Yeah, it's fascinating what's going to happen in the future. Yeah.
On that note, Albert, there's as well a question from Tiago. He's basically asking, can you control the ventilation system with the indoor monitoring devices? Have you got projects already where you are basically controlling the HVAC system?
Yeah, because we have so-called APIs, and also I would say the building management systems. They have also they can also have APIs, and through that connection, we can control we control the climate in certain rooms. Although it's a very difficult one because every room is different, the occupation is different, but it is feasible combining the uHoo monitors with the building management systems.
Yeah, and then when the monitors disconnected from the Wi-Fi, do they automatically reconnect again? That's one question here. Did you have any problems with reconnecting, or maybe Bram can answer that?
I don't see Dan responding. I'll answer that one. Yes, they reconnect by themselves, so you don't have to do anything there. And the point is just to check it regularly, and you'll find out, because especially in a school environment, for example, some students will take out the plug and use it for something else because they need to connect to the laptop or something. So you always try and find the right spot to place the sensor, and sometimes it doesn't work. So you will always have to check for those kinds of things, of course. But it's low maintenance. You place a sensor and it will do it by himself, and you can check it once a week or once a month, depending on the environment.
Yeah,
and also we're giving regular firmware updates, and so to the app you get a message that there's a firmware update, and sometimes you need to unplug it, plug it in again, and then it's immediately connected to the internet.
Yeah, that was a question from Daddy. What is the maintenance required? And as well, whether there's a different product for home and commercial, and are the parameters the same or similar? Maybe Albert, you can just clarify that in addition what.
We have at the moment two versions. One is the smart home version, we call it. It has we are measuring 9 parameters. Then we have I would say a commercial one for buildings, which is measuring 15 parameters. And so there is, and I think for schools, the home version will do. I'm assuming because they are less expensive, and the schools also facing difficulties with funding. So the home version will do for schools, and but preferable, you should install the Aura because you're measuring the whole indoor environment. Yeah.
There's a question in the chat about calibration and accuracy. Maybe that we can add that on.
Yes, that means that the sensors are being tested, and there's a regular test during the whole life cycle of the sensors if they are measuring accurately. We have developed kind of a program for that, and so it has been looked at if the sensors are doing what they're supposed to do. Yeah,
and they self-calibrate, right?
Yeah,
on an ongoing basis. Great. We have a question here from Alan. Could you show the CO2 readings measured and where the IAQ sensors were located with respect to doors, windows, passages, and height from the floor level? Alan is a very precise guy. He wants the details from you. If you can't show it now, Bram, maybe Alan can get in touch with you subsequently. What do you think?
Well, I saw the question come up, So I already looked up the data. So that's good. I'll show you in a second. There were two parts to the question. One was CO2, the other one was placement. I think I answered placement of the sensors in the previous question, where, well, there's some logical ways. And also, if you've seen the uHoo, it's a sensor that you place on a table. It's something that measures on the location where you are. So height from the floor, table height. That's one I didn't answer. I will share my screen and show you the data of those measurements. It's a bit of a messy graph, and that's because you see the data of 35 sensors in one graph, and you see it from multiple weeks. And this is based on hourly averages. So we're really going into detail now, which I never mind, but I'll try and keep it short. But you see here about 6 weeks of measurements, and you see 1 week where there's no high peaks, which is a holiday. So there we really see the difference in the performance without any students there. And because this is hourly averages, you also see that reaching 1200 or surpassing 1200 means that there's been a short time as well where the CO2 level has been higher. So that's where you really lose performance, learning capabilities in this specific room. Is this the worst we've ever seen? And no. Is there room for improvement? Definitely. And if that is easy to improve, you should definitely do this. So if you have easy access to changing the schedule of the students, or can put a little bit more time between the use of 2 rooms, so using one classroom twice, or using this one once and another one once, it also has some influence, because you give the other classroom more time to restore to the normal CO2 values. So you have some influence there, and then you really should try and do those things, because it doesn't cost anything extra, and then you really improve the environment that you offer to the students, which they will feel.
We have Elijah asked a couple of questions in the chat. One is, how long did you conduct the measurement for the CO2? What should be the maximum CO2 level, or the CO2 that is recommended? And how much minimum fresh air should be coming per student in cubic meter per hour? So very technical question here.
Yeah, well, I like the technical questions, of course. Those are right up my alley. So the CO2 levels, well, what we keep as a standard at the uHoo indicator, if you look at the app, you have the numbers are green, orange, or red. So below 800 is green, it's considered very good. From 800 to 1200 is considered average, not great, but acceptable. And above 1200, we really recommend that you act. Is it possible to have worse CO2 levels? Definitely, but performance will go down and you will feel a bit drowsy, as Matthias told about his meeting room where there was no ventilation. I've measured 6,500 one time in a home from people who on Christmas had people over and there was no ventilation whatsoever. It does not cause permanent damage. CO2 effects are reversible up till some point, which I did have to check with the 6,500, but generally it's reversible, unlike PM 2.5, unlike particulate matter, for example.
Yeah.
Bram, we are running out of time. Did you guys use UVC lamps? And there are 2 additional questions, one on the virus index. I suggest the person gets in touch with Albert subsequently. Yeah. And another one was on budgets. Again, we do an exit poll now where you can identify whom you want to follow up with, and then they will get in touch. So just in 10 seconds, any UVC lamps used? Bram?
No, not used. And I can talk an hour about this, so you can contact me.
Great. Let's do the exit poll. We will, let me just get into the quickly so you can do your follow-up. It's launched here. Whom do you want to connect with subsequent? I think Bram will get loads of connection requests because there are a lot of technical questions still that people are answering. So please tick the box whom you want to follow up with. But surprisingly, at the moment, someone is ahead of Bram. Let's see who is that in a minute. Will this recording be available? Yes, the recording will usually be made available, and as well the PDF of the presentation slides, if both speakers agree with that. Dan and Bram, you're okay with that? Thumbs up. Excellent, good. They nodded. Let's see here what is the follow-up from people that they want. I will end it now. And Albert was leading, but just in the last second, Bram overtook him with 67% want to follow up with you, Bram, 58 with Albert, 25 with Dan to learn about the sustainability factory, and only 8% with me. That's life. Just kidding.
We work all together, so that's great. No problem.
Yes, yeah. Yes, great, excellent. We will see a quick video, and you will get as well a follow-up message from uHoo with a little questionnaire. It would be great if you guys could help us with that. Purpose of continual improvement, and hopefully as well answering your additional questions. So we will see the video now, right? Before we finish officially.
There is a high chance that the coronavirus can easily spread among students and teachers in campuses. The quality of the air you breathe inside schools affects the risk of survival and spread of the virus. Poor indoor air also impacts students' health and learning performance. Failure to act on these problems can lead to potential liability issues for your school. There has never been an easy way to deal with problems in the air. Until now. uHoo Aura continuously monitors all the important things in the air, so you know exactly what to do to improve it and reduce coronavirus risk. View real-time data of all your classrooms and school halls and manage them from one dashboard. Get alerts if any place exceeds safety limits so you can immediately take action. You'll get tips on what actions to take to reduce the risk and ensure the health and safety of your students and teachers, 24 hours a day, 7 days a week. uHoo, take control, ensure safety, reopen safely.
All right, guys, time to take control. Happy Tuesday afternoon and or morning to everyone. See you again next month. And thanks to all the speakers and to uHoo for setting this up. Bye-bye.
Okay.
Great to
Bye-bye.
see you. Bye-bye, everyone.
Bye-bye.